Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of cloud computing. We'll dive into key concepts like installing cloud platforms and performance evaluation, features and functions of cloud computing platforms. Let's get started. Slide 1. Installing cloud platforms. Introduction. Cloud computing platforms are the backbone of modern IT infrastructure, offering scalable, flexible, and cost-effective solutions for businesses and developers. Installing a cloud platform involves setting up and configuring various components, including virtual machines, storage, and network resources, to ensure efficient cloud operations. Steps in installing a cloud platform. 1. Selecting a cloud provider. There are multiple cloud providers, including AWS, Microsoft Azure, Google Cloud, and OpenStack. The choice depends on factors such as cost, features, scalability, and security requirements. Example: a tech startup may choose AWS for its scalable computing power, while a government agency may opt for a private cloud like OpenStack for security reasons. 2. Setting up cloud infrastructure. The step includes provisioning virtual machines, VMs, storage, and networking configurations. 3. Installing cloud management tools. Cloud platforms use tools like Kubernetes, VMware, or OpenStack to manage resources efficiently. 4. Configuring security and access controls. Security settings include firewalls, access control lists, multi-factor authentication, MFA, and encryption to protect cloud assets. 5. Deploying cloud applications. Once the infrastructure is ready, applications such as databases, AI models, and business applications are installed. 6. Monitoring performance. Tools like AWS CloudWatch, Azure Monitor, and Google Cloud Operations help track resource utilization, system health, and security threats. Significance. Installing cloud platforms properly ensures efficient resource management, security, and scalability, making cloud computing more reliable and cost-effective. Slide 2. Cloud platform deployment models. Cloud platforms are not a one-size-fits-all solution. Depending on an organization's requirements, cloud services can be deployed in different models, each offering unique benefits in terms of scalability, security, and cost. Types of cloud deployment models. 1. Public cloud. Owned and managed by third-party providers. Resources are shared among multiple customers. Example: AWS, Google Cloud, and Microsoft Azure provide public cloud services. 2. Private cloud. Dedicated infrastructure for a single organization, providing higher security and control. Example: a banking system running critical operations in a private cloud using OpenStack. 3. Hybrid cloud. A combination of public and private clouds, providing flexibility. Example: a company stores sensitive data in a private cloud but uses a public cloud for customer interactions. 4. Multi-cloud. Uses multiple cloud providers to reduce dependency on a single vendor. Example: an e-commerce company using AWS for computing and Google Cloud for machine learning. 5. Community cloud. Cloud infrastructure shared by organizations with similar needs, such as government agencies or healthcare sectors. Significance. Deployment models help organizations balance performance, security, and cost effectiveness. Slide 3. Cloud platform performance evaluation. Cloud platforms must be continuously evaluated to ensure they meet business needs in terms of performance, availability, and cost effectiveness. Evaluating cloud performance involves analyzing key metrics. Key performance metrics. 1. Latency. Measures delay in processing cloud requests. Lower latency is better for real-time applications. 2. Throughput. The number of requests or transactions processed per second. Higher is better. 3. Scalability. The ability to handle increased workloads dynamically. 4. Availability. Uptime percentage of cloud services. 99.9% plus is the industry standard. 5. Cost efficiency. Ensuring that resources are used optimally to avoid wastage and unnecessary expenses. 6. Security performance. Evaluating the ability to detect and respond to cyber threats. 7. Energy consumption measures power usage in cloud data centers, ensuring energy-efficient operations. Example. IaaS EC2 instances optimized for high-throughput applications have a latency of 5 milliseconds, ensuring fast data processing. Significance. Evaluating performance ensures that organizations optimize their cloud spending and improve reliability. Slide 4. Features of cloud computing platforms. Cloud computing platforms provide a range of features that enable businesses to operate more efficiently. These features help in managing workloads, securing data, and ensuring seamless performance. Key features of cloud computing platforms. 1. Elastic computing. Cloud platforms dynamically scale resources up or down based on demand. 2. Virtualization support uses VMs and containers to run multiple workloads on shared hardware. 3. Multi-tenancy. Enables multiple users to share cloud infrastructure securely. 4. Storage and backup services provides object storage, e.g., Amazon S3, block storage, and database backups. 5. Security and compliance. Cloud platforms have built-in firewalls, encryption, and regulatory compliance. 6. Automation and DevOps integration supports CI/CD pipelines, automated deployments, and monitoring tools. 7. AI and big data integration. Cloud services power machine learning, data analytics, and automation. 8. Hybrid and multi-cloud support allows businesses to connect multiple cloud environments seamlessly. Example. Google Cloud AI enables businesses to train and deploy machine learning models efficiently. Significance. Cloud computing features enhance scalability, security, and operational efficiency. Slide 5. Advantages of cloud platforms. Cloud platforms have transformed how businesses operate by offering flexible and cost-effective solutions. Key advantages of cloud platforms. 1. On-demand resource scaling. Cloud platforms adjust computing power, storage, and networking based on workload demand. 2. Cost savings. Pay-as-you-go model eliminates upfront hardware costs. 3. Remote access. Cloud services are accessible from anywhere, improving productivity. 4. Disaster recovery. Built-in data backup and recovery mechanisms prevent data loss. 5. Security and compliance. Cloud providers follow industry standards like GDPR, ISO 27001, and HIPAA. 6. Automatic updates. Software and security patches are managed automatically. 7. AI and big data analytics. Cloud services power real-time analytics and predictive modeling. Example. Netflix relies on AWS cloud infrastructure to stream content globally. Significance. Cloud platforms enable business continuity, security, and operational efficiency. Slide 6. Disadvantages of cloud platforms. Despite the many benefits, cloud computing also has challenges that businesses must address. Key disadvantages. 1. Internet dependency. Requires stable and fast internet connectivity. 2. Security risks. Data stored in the cloud is vulnerable to hacking and breaches. 3. Vendor lock-in. Moving to another provider can be costly and complex. 4. Latency issues. High demand may cause delays in processing requests. 5. Compliance complexity. Organizations must adhere to multiple security regulations. Example. A company using AWS faced high data transfer costs when migrating to another provider. Significance. Businesses need proper cloud planning to mitigate risks.